In this video, we're going to focus on getting the length of lines with Euclidean geometry. Okay, so they've given us a whole bunch of information here. Let's get that marked off on our sketch. Yeah, it's much better. And now we are asked to calculate the radius of the circle. We can see it sitting over there. And I so desperately want to do Pythag in this triangle, but I need another side to pull that off. So we're going to come here to this 12 units and we're going to use a Euclidean geometry theorem. And that Euclidean geometry theorem is line from center perpendicular to the chord. If you have a line from the center that is perpendicular, aka 90 degrees to the chord, it's going to cut my chord in two equal parts, aka bisect it. So I know that AE is the same length as EB for this reason here. Line from center perpendicular to chord. And we're going to state it just like this. AE equals EB, line from center perpendicular to chord. And then if this is 12 units, I'm just going to halve that to get the length of both of these sides. So if I halve that, it gives me 6 units. So now you can see I've set myself up for the Pythagoras part. And the Pythagoras theorem states that your hypotenuse squared is equal to the sum of the other two sides squared. So the hypotenuse over here. To identify it, your right angle just points at it. So you see this right angle here, it points at the hypotenuse, so the hypotenuse is R. So I'm going to switch out this H to an R. And then in A's place, I can literally put any one of them. I'll just put the 5. And in B's place, I'll put the other side, which is the 6. Okay, and we do not take chances here. We pump that in, press equals, and we get 61. And then all that's left to do here is to get rid of that square. And I'm going to accomplish that by square rooting both sides. And then I'm just left with the radius to be the square root of 61. And they do want the answer in third form, so I'm going to leave it just like that. And then I slap a little units there, and then I'm officially done. And quickly having a look where these 4 marks come from. We get 1 mark for this statement, 1 mark for this reason, 1 mark for the Pythagoras statement, and then our answer as a third form gets us our last and final mark here. And in 5.2, we've been asked to calculate the value of x. Now x is over there, it's in a completely different triangle. So we've got to somehow start working with this triangle. And I just know the length of one side of that triangle. So let's see what we can do. So if I have a look at this triangle, this side over here, see, oh, it's a sneaky weasel, my bro. There's a radius alert, he's on the loot. So we know that the length of CO is root 61 units. Because it's radius, this is also a radius and we know its length. So let's see how we state that. So we're just going to say OC is the same size as OA because they are both radii, and we just slap on the physical size next to that of root 61 units. Now I'm ever so close to getting x. I can use this triangle, but there is a problem. I want to apply Pythag over here, but I can't because I don't see a 90-degree angle. So I'm going to have to use the following Euclidean theorem to bring that 90-degree angle into the picture. So it's called line from center to midpoint from chord. If I've got a line coming from the center that goes to the midpoint of this chord, aka the chord is bisected, then I can conclude that this little angle here is 90 degrees. So we can see that happening here. We've got a line from the center that goes to the midpoint of the chord CD. I know it's the midpoint because of these two little lines over there. So we know that F1 is 90 degrees for this reason. Line from center to midpoint of chord. And now that I've got the 90 degrees in my triangle, I can clap some Pythagoras. But right, so let's get the Pythagoras theorem going. Okay, so the hypotenuse squared, so the 90 degrees points at the hypotenuse, so I'm going to replace it with the root of 61. Okay, and then I can put any one of these two sides into A's place. So I think I'll just put the X in there. And then the last side will have to go into B's place. So I'm going to put the 7 inside of B's place. And now the mission is to solve for X. So root 61 squared is just 61. The square and the root cancel out with one another. And as always, if you're not too sure, just triple check it with your calculator and yeah, you'll see number 1. And 7 squared will give me 49. And then I'm going to take that 49 over to the other side of the equation. And it becomes minus 49. And 61 minus 49, I believe that's 12. And it most definitely is 12. Triple check yourself. And now we just need to get rid of that square. And we're going to get that done by square rooting both sides. And then we're going to pop that into our calculator. So if I pop it in, press equals, it gives me 2 root 3. So I can list my answer like that, or I can hit the S to D and list my answer to 2 decimal places. And just make sure whichever one you list, you clap the word units next to it. So let's have a look where the 3 marks come from. First mark comes from telling me that F1 is 90. Second mark comes from the reason for that. And the last mark comes from the statement for Pythagoras.